All right, today we're going to talk about the absolute value function. Our main focus is to look at the key features of an absolute value graph, just like you did in Math 2 with the quadratic and the square root. We're going to do the same with the absolute value, but before we get to that, I wanted to review what you already know. What is the absolute value function? So you've seen this probably in earlier maths, probably in middle school, and I just want to refresh your memory on it. So what are opposites on a number line? Opposites on a number line are two numbers that are the same distance from 0. Okay, so if I have 0 right here in the middle, and then I have 1, 2, 3, 4, and then I'm just going to put 5 over here. -1, -2, -3, -4, and -5. Okay, so distance from 0 is what you're looking at. So if you look at +1, the distance from +1 to 0 is a unit of 1. And then the same distance from 0 to, and then it's also the same as 0 to -1. That is also 1 unit. So -1 and 1 are said to be opposites because they're the same distance from 0. They're just in different directions. Okay, same thing as 2 and -2, because remember, distance is always positive. So no matter what direction you're going in, your distance is positive. Okay, so the same thing with 2 and -2. 2 is 1, 2 units from 0. -2 is also 1, 2 units from 0. So -2 and 2 are said to be opposites also. And I could keep going with that. So, but what is the absolute value? An absolute value is the distance a number is from 0. Okay, and remember, distance is always positive. So don't think of it as absolute value makes everything positive. I mean, it does, but it's showing you the distance. Okay, so if we go back to this slide, the distance from 0 to 1, you already know is 1. And then the distance from 0 to 1, you wouldn't say that -1 is -1 units from 0. You would say -1 is 1 unit from 0. Okay, and that's what the absolute value does. It calculates the distance, which we know is always positive. All right, so how do we denote the absolute value? We use this symbol right here. Okay, that is the absolute value symbol. And it is red, so you would read that as this is the absolute value of x. And in this problem right here, you would say, what is the absolute value of -3? Well, what is the distance of -3 from 0? 3. Okay, what is it? So the next one would be the absolute value of 5, and that is going to be 5. And then the absolute value of 0. 0 is neither negative or positive, so it's just going to be 0. Okay, so what general statement can you make about the absolute value? Is that it makes everything non-negative. Okay, so an absolute value, do you see any of, and so I want to look at the x values versus the y values. So our x values are the, as you can tell, are the ones inside the absolute value, and then our y values are going to be our answers. So if you look at the x values, you see a mixture here. You see there's a negative, there's a positive, and there's a 0, correct? So we can say that inside the absolute value, it can be a negative number, correct? But if you look at the y values, take a look at your y values, which we're going to say are our answers in this case, okay? Are any of my answers negative? No, they're not, because we're talking about distance here. So is it safe to say we can say that an absolute value cannot equal a negative number? Okay, so we're going to say the absolute value of x cannot equal a negative number. That is really important when we get to solving absolute values, that you remember that an absolute value of x isolated, okay, I want to say isolated. See how there's nothing behind here, there's nothing in front. See, nothing in front, nothing in behind, okay? So an isolated absolute value of x cannot equal a negative, okay? Now, let's look at some absolute values that are not isolated, okay? And make some conclusions. So if you look here, these are some there's one isolated and there's some non-isolated. So if you look at this first one right here, you see how there's a negative out front? That makes this a non-isolated absolute value, okay? And so when you see that, you need to remember your order of operations, okay? The absolute value symbol is kind of like a grouping symbol. Well, it is a grouping symbol. And you need to take care of what's inside that grouping symbol before you can do anything on the outside. So the absolute value of 23 is 23, okay? So now we've handled that grouping symbol, we have negative 23. And there's nothing left to clean up. So my answer here is negative 23. Now on that last side, we just said an isolated absolute value can't equal a negative. But again, if you look here, this is non-isolated. You see that negative? So therefore, it can equal a negative, okay? So an isolated absolute value can not equal a negative, and a non-isolated absolute value can equal a negative, okay? All right, so the next one is isolated, so it cannot equal a negative. So again, you handle the inside first, clean it up. 6 minus 5 is 1. 1 plus 4 is 5, okay? And the absolute value of 5 is 5, okay? And it gave me that positive, which is what we needed. Now this one, the last one, it is also non-isolated, okay? So therefore, you have a chance of it being a negative number. So again, handle the grouping symbol, okay? So the absolute value of negative 2/3 is positive 2/3. And then we have to bring that negative over, and that would be our answer, okay? All right, so that is if I give you your x's and you're looking for y, but what if you're looking for your x and I give you your y? Now we're going to do a simple one. We're going to get into more complicated ones in another lesson. So what if the variable is in the absolute value sign? So this is saying the absolute value of 7. What this means is asking what are all the solutions that can make this statement true. So it is saying what are all the numbers that x can be to give you positive 7. So remember, it means distance. So this is saying that what numbers are a distance, or we'll say it differently, are 7 units from 0. Okay, so what numbers are 7 units from 0? Well, definitely positive 7, right? But then also negative 7. Positive 7 is 7 units from 0, and negative 7 is also 7 units from 0. So x would be negative 7 and positive 7. Okay? But again, don't stress about that. We're going to talk about that later. I just wanted to point that out to you right now. Okay? All right, so now let's get to what we really need to talk about. It is the key features of an absolute value. So now we're going to look at the graph. It's always nice to look at the graph before you start solving because the graph can tell you so much about a function and so much about your solutions. Okay? So here are two absolute value equations, absolute value graphs. So an absolute value equation, so when you learn quadratic, you learn the vertex form. Well, most functions can be put into a form of vertex form, and that is what this is. This is your basic equation of an absolute value. Now, we're going to get into more depth when we look at transformations to what the A, H, and K are and how they move the graph. But we're going to talk just about what they mean right now, vocabulary-wise. So every absolute value equation has a V-shaped graph, okay? It does not curve. It does not do a loop. It is straight V. Okay, so an absolute value function forms a V on your graph. Now, there are two ways it can open up, just like a quadratic. The V shape can open up if your A is positive. So if this guy right here is positive, it's going to open up. If this guy right here is negative, it's actually going to open down. Okay, and you really need to know that. Okay, so if A is positive, it opens up. If A is negative, it opens down. Okay? All right, so let's talk about some vocabulary. The highest or lowest point on the graph of an absolute value function is called your vertex. Okay, so if we go back to this slide, if you look right here, let me get a brighter color so we can see that. So if you look right here, this is what we call your vertex. Okay? And if you look on this graph, that right there is your vertex. Now, It is either your highest or your lowest point. Either means one or the other. It's not both. You either have a max or you either have a min. Okay, you cannot have both in an absolute value. So if you look at this first one over here on the left, this vertex we would call a min because it is the lowest point of the graph. And then over here on this other graph, you would call that a max vertex. Okay? So an axis of symmetry, just like your quadratic function, we have an axis of symmetry. It is a vertical line that divides the graph into a mirror image. Now, your graph, your calculator or Desmos, neither one are going to show you this axis of symmetry, but it's just an imaginary line that cuts the graph in half. It goes right through the vertex, okay? Right through the vertex. That is called your axis of symmetry. It splits the graph directly in half, okay? So an absolute value graph has one axis of symmetry, like I just said, that passes through the vertex. Now, here, let's talk about your y-intercepts and your x-intercepts. The point where your line or curve touch, so what is a y-intercept? It's the point or line, it's where the line or curve touches the y-axis. That is called your y-intercept, okay? Now, in your parent function, your y-intercept and your x-intercept is the same thing, okay? But that's not always going to be true, and we're going to do some problems where it's not. But if you look right here on this graph, that is your y-intercept because it's where the graph crosses the y-axis. And then your x-intercept is also where the line or graph touches your x-axis. Okay, and like I said, in the parent function, they are both the same. Okay? Now, zeros. So your x-intercept, as you've probably noticed from previous maths, it has multiple different words you can use. And so I wanted to talk about another word that we call x-intercepts. We also call x-intercepts zeros. Okay? So a zero of a function is where it's what values make this equation zero. Okay? And if you look on this graph, the graph where x equals -3 and x equals 3 is where the equation would equal 0. Okay, it's basically what we call the solutions also. It's what can you plug into this equation and give us 0. But they're also your x-intercepts. Okay, and as you can see here, these are my x-intercepts, correct? And if you look, my y-intercept, let me change colors. My y-intercept is different here because this isn't my parent function, okay? So if you look, right here is my y-intercept, okay? But I also wanted to talk about zeros versus y and x-intercept. If you look on this previous slide, when I asked for the y-intercept and the x-intercept, we put it in coordinate form, okay? So if I ask you to tell me what is the y-intercept, what is the x-intercept, I expect the answer to be in coordinate form. But if I ask for what are the zeros of this function, then you need to say x equals blah, 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 okay? So if I ask you for the y-intercept or x-intercept, I need it in coordinate form. But if I ask you for the zeros or solutions to this equation, I'm asking for what does x equal when y is 0, okay? All right, so we just did a video on domain and range. And now let's talk about domain and range with your absolute value. So domain is easy peasy with absolute value. The domain is always going to be the set of all real numbers. And we notate that in interval form as -infinity to +infinity. Okay? So this will always be your domain of an absolute value. So if I say, hey, what's the domain of absolute value? You need to spit out -infinity to +infinity. Okay? Now, your range is based off of your vertex. Okay? If your vertex is a max versus when your vertex is a min. Okay? So remember, your range is how low do you go, what's your lowest y value, to what is your highest y value. So if your vertex is a minimum, that's when the graph opens up. So if you look over here on this graph right here is a minimum value, okay? And so it's where the graph opens up. So that means my range is going to be from what is my y value of my vertex to positive infinity. So my y value here for my vertex is 0. So my range here would be bracket 0 to positive infinity. Okay, now if the vertex is a maximum graph, so it opens down, so if we had a graph, let's just draw one right here. So if you had one that opens down, then the range would be, oh, my negative sign went away. Nope. This is supposed to be negative infinity. So if it opens down, the lowest y value is negative infinity, and then it goes all the way up to your y value, which right here would be negative 1. So the range here would be negative infinity to negative 1 bracket. Okay? All right. Now, rate of change, you have seen in Math 1, but you dealt with rate of change with linear functions. Absolute value is basically the same because absolute value is technically two linear graphs put into made to one graph, a piecewise function, which we're going to look at later. So you can find the average rate of change here. Now, our average rate of change is another word for slope. So we're going to use our rise over run to calculate it. And an absolute value function, it has the same average rate of change on each line segment. So the line segment over here on the right is going to have the same rate of change as the line segment over here on your left. Okay? It is also the a value in your vertex form of your equation. That's going to come in handy when we're writing equations from a graph. Okay? So the a value is just your slope. Okay? So to find the a value of this graph, we're going to count rise over run. I rose 1. I ran 1. I rose 1. I ran 1. So my a value here would be 1. Okay, and that's what it is of the parent function. But we're going to look at some graphs where it's not 1. Okay? All right, so let's look at those examples. Okay? So the first example looks like this. Okay, so the first question I ask you is, what is the vertex of this graph? Well, the vertex of my graph is that point down there, which is right there. And it's going to be the point 1, negative 4, okay? So my vertex is 1, negative 4. Now, is this a max or is it a min? It is a min. Does it open up or does it open down? This one opens up. All right, so your x-intercept. So your x-intercept is where this graph touches or meets the x-axis. So this is my x-axis right here, okay? So right here and right here are my x-intercepts. And I'm asking x-intercept, so I need it in coordinate form. So this point right here is going to be negative 1, 0. And then this other point is going to be 3, 0. So those are my two x-intercepts. Your y-intercept is where does this graph cross the y-axis? Well, it crosses the y-axis right here, which is going to be point 0, negative 2. All right, so a value, that is your average rate of change. That is your rise over your run. So to do rise over run, you need to find 2 points and calculate the rise over run between those 2 points. So I'm going to change color so you can see it, okay? So my a value is in green. So I'm going to use this point and this point. And you can use any 2 points you want, but you want the points that hit that grid. And now calculate your rise over your run. So I rose 1, 2, and ran 1. So rise over run is going to be 2 over 1, which is just 2. So 2 is my a value. And you, like I said, could pick another 2 points. So I could come over here and pick these 2 points. Okay? And I rose 1, 2 over 1. So same thing. All right, domain. I told you domain for an absolute value is always going to be negative infinity to positive infinity. Now your range is how low do you go? Whoops. Your range is how low to high. Okay, that's your range. Okay, low to high. So my lowest y value is right here, which is 1, 2, 3, negative 4. And then how high does this graph go? Well, it goes off the graph. So we're going to say that is positive infinity. So my range here is -4 to positive infinity. Okay? All right, next one. So next one, we give you another graph, okay? So vertex. Vertex is that kind of the TP point, okay? Right there is my vertex. And this is going to be -3, 4. So my vertex is -3, 4. Is that a max or is it a min? Is it the lowest point or is it the highest point? So is it a mountaintop or is it a valley? Okay, this is a mountaintop, so it's got a peak, which is going to be your max right there. Does it open up or does it open down? It opens down. Your x-intercepts, where does it cross the x-axis? This one goes off the graph, so you kind of have to draw a little bit more, and that's fine, okay? So if you look, so to do that, let's get down to our a value. So remember when you had linear graphs, you had to keep going with your rise over run to continue your graph and find more points? Same thing here. So if you look, this graph rises 1, runs 1. So my a value here is 1. So I'm just going to keep doing that. I go down 1, over 1. And when I go down 1 over 1, that gives me my other x-intercept, which is -1. Okay? Yeah, that point, and then, so I'm just going to extend my line. So there you go. All I did was just continue my graph. Okay? So my x-intercepts here are going to be -7, 0. That's +1. That is not -1. My bad, guys. And 1, 0. Okay, so my x-intercept is -7, 0 and 1, 0. Y-intercept, where does it cross the y-axis at? Right here. Okay, that's my y-intercept, which is going to be 0, 1. Okay. Your domain, same answer as last one, -infinity to positive infinity. Your range, so remember, your range is how low do you go to how high do you go. So my lowest point here, well, there's arrows pointing down, right? So that means it's going to keep going down into the abyss, which is what we call -infinity. And then how high does this graph go? +4. So my range here is going to be -infinity to +4. Okay? All right. So on this one, I would like you to pause this graph, pause this video and see if you can answer this one by yourself. Okay? So pause it right now, and then when you're done, hit play and check your work. Okay? All right, so I hope you paused the video and I hope you gave this a shot. Okay, and so now let's check our answers. Vertex, it's that peak point, which is right here. So that's going to be 3, -2. Max or a min, is it a mountain, or is it a valley? This is a valley, so it's going to be a min. Does it open up or does it open down? It opens up. X-intercepts, where does it cross that x-axis? Crosses here and here, which is going to be 2, 0 and 4, 0. Y-intercept, where does it touch that y-axis? Right here at 4, which is going to be 0, 4. Average rate of change is your slope. Find 2 points. So we're going to use this point right here and then use this point. I rose 1, 2, and then ran 1. So that's 2 over 1, which is 2. Domain, same answer as the past 2 examples, -infinity to positive infinity. Now your range, it is your low to high. So my lowest point here is -2. And it keeps going up, which we say is positive infinity. Okay, so I hope you got that right. And if you didn't, you found your errors. Okay, and that is it for this video. Thanks.